by the wavelength of visible light. So the smallest distance we can see with light is 200 nanometers. So if we want smaller details, we need a sort of irradiance with smaller wavelengths, and that is what we can get with electron beam. So this is how it looks like. If you think, and here is the filament, which is producing the electron beam, and it's very high voltage. So we get really high speed on the electrons, and so that they are not slowed down, they need to be in vacuum. And you hear the pump, so it's pumping out air. So all the system is in vacuum, and that is very important, all this system. And here is the goniometer, where you put in your little grid. So you take out this here and put it on this little holder, put in your grid, and put it back again. And then you need to pump out the air from the system. Here is a sort of lens. It's not an optical lens, it's a magnet that focus the beam, the electron beam, so that you get the light, the electron beam in focus on the preparation. And then you get the visualized here that you can then see with cameras. It's 2 cameras here. And here you focus. Yeah, so that's how it works. So now we will look at this preparation. And we will look at the culture. It was isolated from Canada, from the Arctic Canada. It was Daniel Volon and his team that were up there and sampled it from the ice, this organism. And they got pure cultures, and they sequenced it, and they realized it was a haptophite that has actually been sequenced before, but it was given a new name. But when I saw this, I said that it's probably the same as what that was described from Finland, that was called Chrysochromina birgeri. And as I said, it was Heidi's father, Guy Helfors, that described it many years ago. So we looked at the scales to see, could it be the same as Chrysochromina birgeri? So then we will now look at Sophie put in the grid that we prepared, the same way as you did yesterday, but with real chemicals, no real difference. So she has already put in the grid, so it's up here, and then she see it on this little screen that you hear. You can see, and she can focus with this within her hand. She focus, so she can be clear, and then she can increase the magnification afterwards, and then put up what she sees here on the screen. It's an advanced instrument, and it creates. It's necessary for really thorough adjustment all the time to keep it properly. So it's always a dedicated engineer that take care of the instrument. But you can also center the instrument for you, make it clear and usable. So here is what we see now, and we see a scale. And this algae has actually 3 different types of scales. You see, they have this, these spines are very typical. So, and these are scales that sit on the cell outside. Plenty of these scales on the outside. And we can also see that it has divided in 4, we call it the quadrant. And they have some ribs here. So what we have done is to count the number of ribs to see if it's the same as the original description. And we realized that it was another 3 types of scales, and so it's another one that also exists here. So we have 3 types of scales, and it's in all respects, except for the third scale, it's similar to the original description from Finland. So this we will call them Pseudohaptorina birgeri. Birgir was the guy at the marine station in Finland that took care of all the practical things. So it's called named after Virgish. So you can see the different things. And you also see some holes and all that. So that's the staining also. And it's the uranine isotope and the osmium that make it electron dense, so that the electrons can't pass there. They just pass where it's white. So you have to stain the samples here. Yeah. This is probably some from the staining that is colors. So we see it's actually, we can see two different scales here. That is one with the very wide, and this is more narrow. And then it's another. So here are the three scale types that you can see. So that is how we identify them. We can see on the shape of the cell, the size of the cell, the flagella, atomema, but to be sure we need to go here. Scales.
If you want to see.
Yeah, if you want to look at into the binoculars.
Oh.